Hey, Hammy here, coming to you with part 1 of section 2.2 on biochemical reactions. First, a little review on what exactly a chemical reaction is and chemical equations and some stuff that you should have learned in physical science. Chemical reaction is a process that changes one chemical substance into another. Okay, so it's going to change its properties. The stuff you're starting with is always called the reactant or reactants, okay, because sometimes you could have two things or more combining, and the resulting substance is the product, or sometimes you'll have products. You'll have more than one thing produced. For example, down here in this picture here, this is an example of methane burning, okay, methane gas. So that is a chemical reaction happening. That burning methane is represented by a chemical equation, okay? And you may have looked at these in physical science. Okay, this side over here are the reactants, and then this little arrow we often say means yields, okay? So the reactants reacting together yields. This side over here is the products, okay? The stuff that is produced. Okay. Now, one thing that you need to notice is Lavoisier said that there must be a conservation of matter. So if we're putting in, if you count the atoms over here, if we're putting in 1 carbon, 4 hydrogens, and here's 2 O2, so this 2 right here is called a coefficient. That means we have 2 O2 molecules. Okay, the O2 molecule, this is a subscript that says that this is a diatomic molecule that's oxygen plus oxygen. So if you have that times 2, how many oxygens total? You just multiply them. So you have 4 oxygens, 4 hydrogens, and 1 carbon. If you look at what's produced on this side, you notice here's our 1 carbon. We have 2 oxygens here. You say, well, we only have 1 here. If there's nothing there, it's like a 1. Well, look, there's a coefficient of 2 saying that there's 2 water molecules. So you have H2O and H2O. How many oxygens is that? 1, 2. So we have 1, 2, 3, 4. That's what we said. And we have 1, 2, 3, 4 hydrogens. So we add these coefficients before some of the molecules to balance, we say balance the chemical equation, because there needs to be the same amount of matter on both sides. You can't magically gain or lose atoms. They all have to be there. All chemical reactions involve energy in some form, okay? And that energy is either going to be taken in to the product, or the reactants are going to react and release energy, and the products are going to be lower energy. A chemical reaction that releases heat, okay, releases heat, are called exothermic. The prefix exo meaning to the outside. So exothermic, thermo meaning heat, the heat is given off. Sometimes you'll see this as exergonic. Okay, exergonic just means that energy is given off, maybe not in the form of heat, but another type of energy. So exothermic or exergonic means heat is given off. For example, this example down here, I put lighting a match. Okay, it's giving off light energy, it's giving off heat energy. Okay, maybe some sound, some crackling as the wood is crackling as is burning. So it's giving off energy, mostly in the form of heat. Okay. Endo means towards the inside, so they're going to absorb energy. An example of absorbing energy, some of you may have maybe fallen in phys ed or something, bumped an elbow or wrist or something like that, and the secretaries may have given you this instant cold pack. They don't have a freezer down there, but there's this pack that they keep in the storage room that's got an inner bag of water and ammonium nitrate crystals outside of that, and then they pop it, they push real hard and they pop that inner bag of water to mix with the ammonium nitrate, and then they shake it up, and when you put it on your elbow that you bumped, it feels cold. Why is that? There's a chemical reaction taking place in there between the ammonium nitrate and the water that is absorbing energy, so it's absorbs heat or feels cold to our elbow, and it helps keep the swelling down and helps with the pain of your boo-boo. Also, when we talk about chemical reactions, when they are graphed and a reaction taking place, so a reaction over time, you'll often see this little spike or this little bump here. Okay, so here's our energy level over here on the side, and then here is our reaction taking place. So this would be time going this way. Notice that there's a bump. That little bump is called activation energy. A lot of chemical reactions need a little kick in the butt to get going. Okay, so you have to put in a little bit of energy and then to get the reaction going, and then you'll notice that you actually end up at a lower energy level. If you look over here at these two graphs, we show our endothermic and exothermic reactions taking place on a graph like this. So over here is the energy of the reactants. You see that this side is lower than over here at the products. And then also you see a little bit of this activation energy bump to get the reaction to go forward. Okay, so the amount from where you started to where you ended, okay, right here, this is the energy that is absorbed. Okay, so it has, like photosynthesis, you start with low energy molecules like CO2 and H2O, water, that don't have a lot of energy, and you put in a lot of sunlight, a lot of light energy, and you end up over here with C6H12O6, glucose, a high energy molecule. So you start with low energy molecules and with high energy molecules. Over here for exothermic would be the opposite reaction, like cellular respiration. So you're going to start with this glucose in our mitochondria of our cells. It's going to take a little bit of activation energy right here to get that process going, and then you're going to end up with your products, CO2 and H2O down here, okay, which are low energy. And then you're going to give off, oh, that's a horrible arrow. There we go. You're going to, okay, that's still pretty bad. You're going to give off a lot of energy here for our cells to use from that sugar. Okay, so photosynthesis would be endothermic, taking in sunlight energy, and then cellular respiration in our bodies and in plants and other cells, types of cells, cellular respiration would break down that sugar and release the energy, okay, to use to move, think, and their daily cellular processes. And finally, when we talk about chemical reactions, we throw this bio in front of it. So a biochemical reaction, what's the prefix bio mean? Bio means life. So biochemical reactions are all those things that are, all those reactions, those chemical reactions that are taking place in living things. In particular, the sum. This is important concept term here called metabolism. You'll hear this a bunch all through Bio 1, Bio 2, AP Bio. We talk about metabolism, the sum of all chemical reactions. In class, I'll show you, I have this big map I got from a science supply company. In real tiny print, it shows a ton of all the biochemical reactions that are happening in the body, and it's almost overwhelming, all the different reactions that have to take place to keep you and I alive and functioning. We break them into two main categories, catabolic and anabolic. Catabolic is breaking down molecules. So if you look over here, we start with a larger molecule, and it's going to be broken down into a bunch of smaller molecules. So now all these little dots, atoms, are not connected. Catabolic tend to be, here you see energy, tend to be exothermic, tend to give off energy. So we break down glucose into water and CO2, gives off energy. Anabolic means building molecules, taking small molecules, so this would be like photosynthesis, Okay, so we're putting in sunlight energy, and we're going to put these smaller molecules together into a bigger molecule. So CO2, H2O, into a glucose molecule, a bigger molecule. You remember that anabolic steroids some people take to try to really bulk up and get big muscles. They're building muscle, making themselves bigger. So you're tearing down the cat and your anabolic steroid building back up. So that's kind of how I always remember that.